How did someone who gets so much basic chemistry wrong discover such a breakthrough, unique, first of their kind formulation? You might have seen Matter of Fact on your social media lately. They're a skincare brand, their star product is a vitamin C serum, and they've been doing a lot of sponsorships with influencers, particularly the ones that come across as sciencey. You might have been surprised to see me in one of their influencer ads recently. I was surprised too because no one asked me, and 3 months earlier I told their founder exactly why I didn't want to do a sponsorship with them or endorse them in any way. So today I'm interrupting our regular viewing schedule to talk about how Matter of Fact annoyed me enough to pause the endless list of content that I'm meant to be working on to spend literal days making this video. Have you noticed that skincare science has gotten really trendy? For us as skincare users, it makes sense. We want to use products that actually work, and understanding the science behind how products work is a really good way of going about it. You can find out what does and doesn't matter, so you can focus on which products actually make sense for your skin and your life. And learning science is just kind of fun. I think skincare science really got trendy with The Ordinary. Suddenly, we all had a reason to learn these complex ingredient names because each product cost less than $10. And while that was cool, I really liked that we all found each other and got to nerd out together. It also meant a lot of brands saw this and started thinking, how do we get in on this?
Babe, what are you doing?
Like and subscribe to help me buy a lock for my room. Look, using science to sell products isn't anything new. On one level, it makes perfect sense. If a brand has invested a lot of time and money into making sure their product works well, then explaining to people how it works, showing them all the testing they've done, is a really great way to show people why they should choose that product. And if science is really trendy, then people are more interested in the details and the brand can show more of the data that they normally wouldn't. Which is great for me, I'm really nosy. But science is hard. You have to study and do lab classes and learn stuff and read papers properly. Or if you don't want to do that, then you have to hire scientists and they take ages to do stuff. Plus you have to pay them the whole time. Why did it take 300 years to get just one number? There, I did that in like 5 seconds. So what if we just... And that's where science washing comes in. Science washing is where you take the aesthetic of science and make things look scientific without actually doing the science part. Things like talking about studies that aren't interpreted correctly, citing studies that aren't relevant and hoping no one looks into them, using scientific words to try to sound smart but using them incorrectly, using numbers and graphs that don't really make sense. You get the science cred without actually having to deal with the rest of the iceberg. And it makes a lot of sense from a profit perspective. Mathematical. And here we come to Matter of Fact, who are one of the most science-washed brands I think I've ever seen. Matter of Fact is a skincare brand that claims to be moving the science of skincare forward with evidence-based breakthrough technologies. Their star product is a vitamin C serum that they say is the most significant advancement in skincare in nearly 2 decades, with unmatched stability, potency, and cosmetic elegance. This is a big deal because vitamin C is an incredible skincare ingredient, but it breaks down very quickly in products. Their founder is Paul Beck. Their launch email describes him as a true multi-hyphenate with degrees from Harvard and Wharton, his degrees are in psychology and business, and a successful K-pop career on his resume. He also worked for 2 years in venture capital, which he doesn't mention much. He was also mentored in cosmetic formulation, specifically emulsion technology. He says he first got behind a bench in 2018, but in a few short months he'd already made this 20-year breakthrough in chemistry, without any proper chemistry training, except his mum has a chemistry PhD. That keeps coming up. He outsmarted all of the thousands of qualified scientists in the cosmetics industry, and his discovery wasn't even in emulsions, the thing he was mentored in. Foreshadowing. Amazing! That explains why his press release says he has a rare yet brilliant mind for both science and art. I first noticed Matter of Fact when I saw the hype around their launch in September 2021. Their ads made some really bold claims about their ascorbic acid serum. It has unmatched stability in the vitamin C space. The ascorbic acid was fully stabilized. Since I am a massive vitamin C nerd, I was really curious. Here's their graph showing the stability of their formula versus the current gold standard with regard to stability. So the obvious question is, what product are they comparing it with? Well, it seems like it has to be the SkinCeuticals CE Ferulic. It's the only vitamin C product anyone calls the gold standard. But it isn't the gold standard for stability. It's the gold standard for effectiveness on skin. CE Ferulic is water-based, and water-based vitamin C serums have a serious disadvantage when it comes to stability because water makes ascorbic acid decompose faster. Matter of Fact actually mention this all the time. So they're comparing their waterless vitamin C serum to a water-based vitamin C serum, which is a different, less stable category of product. It's a bit like saying Ronnie Baker beat the gold standard Caleb Dressel, so he's unmatched in the 100 meters. And then you realize Ronnie Baker is a sprinter and Caleb Dressel is a swimmer. Caleb and the water-based formula are both fighting against extra water. I'm pretty proud of that analogy. So this is really not good evidence for showing that your product is more stable than every other product on the market. So I mildly pestered them about what data they have for their unmatched stability claim. Paul eventually replied to my email 6 weeks later. We had a 2-hour meeting where we talked about the brand and the studies they'd done, and he confirmed that the other serum in the graph is water-based. He said they tested against 3 products in total, 2 water-based and 1 water-free. I don't think you need to know that much about science to know that if you test against just 3 products and only one of them is in the same category as yours, that doesn't tell you that your product is the best out of all the thousands of products out there. Especially since you don't know how long those other products have been sitting on the shelf, breaking down and turning into stuff that can make a breakdown faster. And based on the science, you wouldn't really expect this to be the most stable product. For example, there are silicone-based vitamin C products like this one from The Ordinary. A lot of these use a raw material called Granactive AA20, which claims to be 90% stable for 3 months at 40 degrees in an open container. To me, as a chemist, it seems incredibly unlikely that ascorbic acid dissolved in propanediol can compete with that. Propanediol is a humectant moisturizer, and that is really good at absorbing water. So if you put this in an open container with any amount of humidity, it's going to absorb water from the air. That means even if you start off with pure propanediol with no water, you're going to end up with propanediol and water. And that water from the air is going to make the ascorbic acid decompose a lot faster. The propanediol is basically moisturizing the ascorbic acid. Silicone is the opposite. Silicone can form a waterproof layer around the ascorbic acid, which protects it from water. It's an occlusive, and in this case, the silicone is sealing the water out. The fact that this serum has dissolved ascorbic acid will also make it break down faster. The ascorbic acid can move around a lot more when it's dissolved, which means a lot more will be available to react compared to when it's in solid grains in a thick suspension. So it doesn't really make a lot of sense to say this has unmatched stability in the vitamin C space, unless you have a lot of very convincing evidence to back you up. All of the science that we know about these ingredients so far goes against that claim, so you're going to want to have very strong evidence to overturn that. Testing against just one water-free product just isn't going to cut it. We also talked about the rest of their marketing. I only just noticed this, but the inside of the box lid says facts matter, which is interesting considering, well, the rest of this video. There is a lot of incorrect science in their Instagram posts that I think, again, just really seems to highlight that there's some basic scientific understanding and just really caring enough to fact check missing. For example, there's this post about why vitamin C serums turn brown as they oxidize. They say it's because ascorbic acid turns into erythrulose, and they say erythrulose is reddish brown. I explained how this wasn't correct in my Instagram stories. Erythrulose isn't reddish brown, and there's no way this could be reddish brown. This is something we teach in high school chemistry. For a molecule to be strongly colored, it needs to have something in its structure that can absorb specific colors of light, and this just doesn't have that. About a week after this, Paul did a live where he showed the manufacturer's spec sheet saying that 75 to 80% erythrulose is yellow to orange. Again, I feel like this is pretty basic. If I have a cup of water that's not pure water and it's colored, it's not the colorless water making it colored, it's something else in that glass. And in an oxidized vitamin C serum, you have maybe 5% erythrulose max. It's nowhere near intense enough to be contributing to the color change like they said when they fixed the post. I also love that they mentioned the confusion, like they weren't the ones who were confused. There's also this 3-step thing. Paul's mentioned it in an interview as well, but ascorbic acid decomposes through way more than 3 steps. Plus, it turns into tons of different chemicals, not just erythrulose. I think this might be because he misinterpreted one of my blog posts. Back in 2017, a lot of people were asking me why vitamin C seems to stain your fingers. People were worried that it was pigment or something dangerous happening. I found this diagram in a paper showing ascorbic acid turning into a bunch of different things, including erythrulose, which is a common fake tan ingredient. This made a lot of sense because vitamin C stains look and act a lot like fake tan, so I figured it was probably the erythrulose or some other similar chemical in the vitamin C serum causing it. So I did a blog post and I redrew just those 3 steps from ascorbic acid to erythrulose to make it a bit clearer, because this diagram is just too much for anyone who just wants to know why their fingers are yellow, damn it. I linked the paper and I wrote this little paragraph to clarify that erythrulose wasn't the only product. There are lots of different products and there are way more than 3 steps involved. But I think Paul didn't understand it and he thought what I drew was everything because it turned into this. So in my meeting with Paul, he also said that he's a big fan of my work. He mentioned specific blog posts that he liked and even my Reddit username. I made a joke that I should maybe invoice him for all this free advice, and he said he wanted to pay me to make sponsored posts and also discuss hiring me to work for Matter of Fact. He wanted me to help them design experiments to test their products and check the claims in their marketing. This last part was pretty sus to me. I've been making science content for a long time. I think I'm really good at communicating skincare science. But I'm not a regulatory expert, I'm not a cosmetic claims expert beyond what I did in my diploma and the regulatory certificate that I'm studying. There are scientists who have been working in the industry for decades whose job this is. Why would you hire a skincare science influencer without the right expertise for this? His reason was that regulatory and claims people weren't good at communicating, and he wanted someone who could communicate well. But then you should hire multiple people. Scientists are specialized for a reason. You can't hire a biologist to do chemistry. You can't hire a science communicator and expect them to deal with all of this very industry-specific stuff accurately. And if you are genuinely dedicated to getting the right information out there, empowering people with science, why would you only start hiring people to check the science 3 months after launching? This brand has $10 million in investor funding. They can afford to do all of these really big influencer sponsorships. They should have plenty of budget to pay a random chemist a couple $100 a month to just quickly check their Instagram post before they go live. The fact they don't have this just seems to me like really messed up priorities for a brand that claims they want to demystify skincare science. So this was a big red flag. So I suggested I could help them with their science communication, but not in a public-facing way. He could pay me a rate that was much lower than my sponsored post rate to just fact-check their posts before they went up, and then maybe later down the line I could do public sponsored content once their content was something I was more comfortable with. But Paul wasn't interested in that, and that seemed to me like a pretty big indication that what they really wanted was to use me and my reputation to get them to look good and scientific, rather than caring about actually being scientific and putting out accurate information. They wanted the veneer of credibility without doing any of the hard work to earn it. So I said if you wanted to be a scientific brand that I'd feel comfortable endorsing, they should fix 3 things. Firstly, fix their stability claims because they didn't have the data to make those claims. Secondly, actually fact-check their post properly before posting, so no more of this erythrulose kind of thing. If you genuinely want to educate people but you're not sure about something, then just don't post rather than misinforming people just for the sake of engagement and gaining followers. Thirdly, stop making drug claims in their posts and their sponsored posts. Drug claims are when you say your product changes the structure or function of skin rather than just the appearance, or treating a disease. If your product is a cosmetic and not a drug, then you shouldn't be making these claims. This includes reducing pigment, reducing wrinkles, promoting collagen production, treating melasma, and it includes linking studies where your active ingredient does these drug things. I know it kind of seems like it should be fine to just state facts, but there are regulations around this because drugs go through really rigorous testing to make sure they actually work. Small studies aren't enough to back up these strong drug claims. This is the sort of thing that happens with illegal drug claims. A lot of skincare brands do make some degree of drug claims, but if you're a brand that claims to be scientific and ethical and moving skincare forward, then I think you should really be on top of this. And you especially shouldn't be making the stronger drug claims that the vast majority of brands know not to make. For sponsored posts where a brand has paid an influencer to talk about their product, influencers generally don't know the difference between drug and cosmetic claims. Brands have to sign off on the final draft of sponsored content before it goes live, so I really think it's the brand's responsibility to hire a regulatory consultant and check that all the claims they're making are above board. A lot of brands seem to think that if the influencer makes the drug claims in sponsored content, then it's not their fault. But no, that is not a loophole. It still counts as the brand's marketing claims, just like with any regular ad. This is in the FTC guidelines, and both the brand and the influencer are at fault. Paul agreed that these would be good changes to make. I agreed to have another meeting in the future to discuss working with them again, and I go off on my merry way feeling okay, I guess, about giving free advice to a brand for 2 hours, but they did seem to want to do better, and hopefully this would improve the state of misinformation in skincare. And then a couple months later, I go back and check what happened. For point 1, all the unmatched stability claims are still up. For point 2, which was not making really basic, easily checked mistakes, they've now done a post where they used a reference because, yeah, citing things will make us look credible and sciencey. But they don't seem to understand how references work, and it kind of looks like they've never seen a reference before in their life. Either that, or they really felt strongly about Leslie doing 3 people's worth of work. And then after I posted a story about this, they tried to fix it but then turned her into Bauman Leslie. And then after I posted a story about that, they tried to fix it again and doubled up the title. It still looks like that, by the way. They also put the molecular structure of retinol in a post because chemical structures are science, but they chopped off half the retinol molecule, which makes it a completely different chemical. They actually managed to get rid of the bit that makes it retinol, so I guess this is reti. Hot tip for brands: if you're going to use chemical structures to science up your brand's marketing, the bare minimum you should do is a 3-second Google for the structure. And then, instead of owning up to the mistake, they dug deeper and said,
"You're right. Our design team made a stylistic choice to zoom in on half of the molecule due to its long structure. When we focus grouped it with some of our audience members, they didn't mind since the molecular structure was unfamiliar to them."
I feel like this should go without saying, but you can't change the way chemical structures work just because you focus grouped it. The structure is the molecule. This isn't retinol anymore. It's like labeling this as Africa because your focus group said it was fine. And on point 3, they've now gotten influencers to make sponsored posts comparing their active ingredient to hydroquinone, which is a prescription drug. So I wrote an email to Paul on January 26 about all of these issues, and I still haven't gotten a reply, even though they clearly saw it and went through and fixed everything I mentioned. Well, they tried to fix it anyway. And then on March 13, I get tagged in a sponsored post that an influencer made for Matter of Fact. It says they advocate for women in science like me for Women's History Month, and of course to buy their products for the women in your life. On the face of it, this is kind of like a nice shout out from the influencer who didn't know all of this stuff going on behind the scenes. Although it is a bit weird / against advertising codes to put someone in a sponsored post that you're being paid for without asking them first. But the way influencer sponsorships work is that the influencer sends the final draft to the brand and then they sign off on it before it goes live. So Matter of Fact would have seen me in the draft post and approved this after all of these interactions with them, and still without replying to my email about poor amputated reti after 40 days. Also without checking if they could legally use someone in an ad without their consent. And even though this isn't an ad specifically for their products, it is still an ad. Lots of companies do ads where they talk about their values so you can feel good about them and buy their products. And I don't know why Matter of Fact thought I would be comfortable being used to improve their public image after all of this. Obviously, I complained about this and they eventually took it down after about 2 days. Again, without any sort of communication with me, no apology, I had to ask the influencer to contact Matter of Fact. Also, they blocked my comments from showing up in their posts, which is amazing advocacy for me, I think. I guess the extremely obvious question we're building up to here is, how did someone who gets so much basic chemistry wrong discover such a breakthrough, unique, first of their kind formulation? How did Paul Beck, whose only chemistry background is essentially his mum and his rare and brilliant mind, outsmart all of the qualified chemists in the cosmetics industry, crack the elusive code, and create the most significant advancement in skincare in nearly 2 decades after just a few months? Well, if you look at Matter of Fact's vitamin C patent, which as of now is still pending, it seems like he kinda didn't. This is the breakthrough that Paul claims to have made.
It just boiled down to, is there a way to dissolve high concentrations of ascorbic acid in solvents that are not water? That's sort of where I started, and through a lot of experimentation, found a way to do it. The eureka moment was thinking about other ingredients that were not liquid at room temperature, potentially being co-solvents. And using that framework allowed us to sort of create this new technology.
So he's saying he's worked out how to get more ascorbic acid to dissolve without water. You can only get about 12% ascorbic acid to dissolve in propanediol, but if you add urea, you can get over 20% to dissolve. So that's what the matter-of-fact serum does. Which sounds really neat, but someone else already discovered this 17 years ago. And it isn't like matter-of-fact aren't aware of this, they reference them extensively in their own patent application. Even without much science or chemistry knowledge, I think it's pretty obvious that this 2007 patent is about using urea to help ascorbic acid dissolve in polyol. Apart from this, which someone else discovered first, I can't really see what's so innovative or breakthrough about this formula. It has other antioxidants, ferulic acid, and a plant extract, but every other vitamin C serum on the market also has antioxidants. The 2007 patent covers formulas with antioxidants. Maybe it's the fact this combination is stable, but testing someone else's discovery doesn't mean you discovered it. It looks like he might have seen what he thought was a potential loophole and tried to file a patent for that. The two 2007 Zhang patents listed examples of polyol solvents that were covered, but one of the patents didn't list 1,3-propanediol, which is the solvent used in matter-of-fact. Matter-of-fact mentioned this specifically several times in their claims. I'm guessing Zhang might have left it out because it wasn't a common skincare ingredient back then, or maybe he just forgot because he did list it in his other patent and it's covered under polyols anyway. Here are all the polyols that Zhang listed in his patent claim, and here's matter-of-fact's 1,3-propanediol. I'm not a patent attorney, so I don't know if this patent will get past pending. The rule is that patents need to be novel and not a trivial or routine advancement on an existing patent. If it's very similar to an older patent, they often decide that it's covered by the original. If this is what he's claiming to have discovered, what's essentially a typo, and I would think it's covered under the old patent anyway, legality aside, this just doesn't seem much like a eureka moment to me. 1,2-propanediol, 1,3-propanediol, and 1,3-butanediol are really similar chemicals, as you can guess from the names. They're used interchangeably in skincare. It really doesn't seem to me that this is a truly new technology or that Paul actually created it. Biggest breakthrough in 2 decades seems like a pretty big stretch. So at the end of all of this, is matter-of-fact's formula fully stabilized with unmatched stability? Well, I don't think so. I was sent these bottles in December, they expire in August 2023, so I'm guessing they were made August 2021. And they've already started going a lot yellower than when I first got them. I talked to someone else who was sent the products around the same time, and theirs is actually even more yellow. You can see how colorless they're meant to be in their promo videos. Compared to these other products that I've had for years, well, you can see the difference in color. And I think that's because maybe they didn't test the product properly under real-life conditions. All the data they show for their stability claims are with accelerated testing. So they kept the product for 8 weeks at 40 degrees Celsius to approximate what would happen for 16 months at room temperature. Things react faster at higher temperatures, so we use accelerated testing to get an idea of whether something's likely to go wrong with a product without having to wait as long. But it's still an approximation. Things happen at room temperature that don't happen at 40 degrees and vice versa all the time. And this is particularly important for vitamin C. Its degradation depends a lot on temperature, so accelerated testing is a lot more inaccurate than normal, and you can't really say that these are equivalent. But matter-of-fact don't seem to know, or maybe they don't care about this pretty important caveat. They hardly ever mention it's approximate, they just keep saying it's been tested for 16 months. And I think the packaging is another big issue. Heat doesn't speed up how quickly oxygen and water leak into your packaging the same way it speeds up chemical reactions. This is an airless pump, but most airless pumps aren't properly airtight. In a standard airless pump, which is what this looks like, air can get through the seams and through the pump dispenser. And given how easily the pump top came off when I opened the tube a few days ago, I'm not really convinced this connection is tight enough to keep propanediol free from water and oxygen. And before anyone says I'm being unfair because I made it oxidize by opening it up, I showed you the serum from this tube, which I don't know how to open, and it's the same color as the other tubes I have. So these claims of 16-month, 24-month stability aren't really backed up by their testing. Again, I don't blame influencers for this. These are things about vitamin C that I didn't know 5 years ago, even with a chemistry PhD, even though I was so deep in skincare science. I know cosmetic chemists with decades of experience who don't know this stuff because they haven't worked with vitamin C. This is why expertise is specific. There's just way too much information to know everything. At some point, you have to trust what experts say. You have to trust that people presenting themselves as experts are responsible and self-aware enough to say when they don't know something, to check with someone who knows more. Matter of Fact and Paul gave them this info and signed off on their posts. They're meant to know what they're doing. Here's the guy who made the biggest discovery in 2 decades. They're the brand moving the science of skincare forward and empowering consumers. And this is really the root of what's wrong with science washing. People and brands who pretend to be experts but continually put out misinformation because they want to save time or money or look smart, they make it so much harder for consumers to work out who to trust and which products to use. I love talking about skincare science. I love that so many more people care about it now. I love that we have a beauty science nerd community. I love that I've met a lot of really inspiring experts and science communicators through this. But I can't deny that there was a lot less misinformation and it was a lot easier to spot the misinformation before everyone decided they needed to science things up.